Yes.
Okay. First, the unit is scalability.
Okay.
Like the capability of changing site. Like in that measurements is access the highest workload under which system will still meet the performance requirements. And device efficiency, and one more unit is accessibility. In that the measurements is user friendly interface, like easy to access. For
Okay.
example, in GUI you can easily pick the icons to work on it, just like user friendly interface. And compatibility unit is compatibility, and the measure is a system can coexist with another system.
Okay.
And next unit is protection. System or software will be protected from malware attacks, like ability of system to operate without catastrophic failure. And functionality feature, set capabilities, security should meet the user needs. And allocation, how much information need to share from one system to another system. And transparency, solution or product either service being delivered within the time, like related to delivering requirements. That's it.
Okay, that sounds good. Any question you have?
Can you explain me delivering requirements with example?
Delivering requirements with example means? Get you.
Like I just want to draw a unit for that and property and measurement. I was unable to make a unit and the measurement
Unit for what? Delivery.
Delivery requirements. Like in organizational requirements, we have delivery requirements. That.
Okay. And the organization part, yeah. Let me share it, and then we'll talk about it.
Sure. And also interoperability. The two I have like a small doubt on those two.
Okay. So interoperability. Okay. Interoperability is outside, something which is beyond your control. Correct? Which is depending upon now how many systems, okay, is interacting with your system. How many systems are interacting with your system? That is your interoperability requirement. How many systems it's connecting to, right? There also you can talk about, we generally talk about hardware, software, okay, interoperability. So when you look at your software, there are three types of interfaces. One is human interface, where you go and work with the software.
Yes.
Second thing is a software taking information from another software. Okay. So let's say if you're talking about a reporting software will take data from your ERP database, let's say. So that's the software interface. Then your software hardware interface. Okay. Like your access card reader, right? Access card reader is a hardware device, and it's going to connect to say attendance system. Attendance system is a software, right? So interoperability, how many distinct systems is it interacting with? Okay. how many hardware components it's interacting with directly, how many software components it's interacting with. Okay, human is not a problem because human interaction will happen. Okay, the system hardware software can fail, software can fail, right? So so you look at all these number of systems basically. There also you can decide number of systems interacting which is controlled by your company and something which is not controlled by your company. External systems, internal system versus external systems. So let's say when you are doing this payment thing, right? Your software is like, when you go to a hospital or restaurant, you swipe your card. So the restaurant's software is internal system. Hospital software is internal system. But the card machine that has to interact, okay, it's like payment gateway, what we call payment. So your system, okay, your system has to interact with this payment gateway. Payment gateway has to interact with the card company. So that is not considered because that is the headache of the payment gateway system. But what is important for us is our system connecting or interacting, okay, with the payment gateway software, right? So that's the external system. So how many hardware it has to interact, how many softwares it's interacting, how many software, or I can say how many external systems it's interacting with, right? So that could be number. Basically, it's a number of dash, number of hardware, number of software, number of internal software, number of external software, right? Those things we can talk about.
Okay.
That's interoperability. Then you said delivery requirements, right? The delivery is organizational. So it is as a team, what is the delivery performance? Okay. Have you delivered on time? So quality of delivery, right? Generally, how many bugs were found after you delivered within say first 6 months or first 3 months or first 1 year?
Okay.
Right? Did you deliver it on time? How soon or how late was the delivery? Quality done, time done, budget, right? How much percentage did we exceed our budget?
Okay.
So these are about quality of a delivery, timeline, quality, cost. Okay. And now we'll talk about people, right? So how many extra people you had to employ to complete this, right? You had planned to, have 50 people on board, right? But you ended up using 60 because of some issues, 55. So 5. So the resources, okay, cost, timeline, and quality. These are the generally there are 4 factors that is related to your delivery.
Yeah.
Right? So it could be that.
Okay.
Any other question?
No. Only these questions.
Perfect. Anything else you want to share? Anyone wants to share?
Yeah, you gave another assignment for making notes on the business requirement, user requirement.
Yes. You want to speak or you want to share your screen?
I just I wrote it down and took a picture of it.
Sure.
Yeah.
Feel free to share.
I'll try whether I could share it.
Yes. Pictures are allowed to share. Okay. Even in business, you can share. Yes.
Yeah.
I made you the host.
Can you wait just a minute? Let me add all the other pictures.
Yeah.
Can you see the screen, Saurav?
Yes.
Yeah,
So,
this is
the business requirement to manage effortless tasks on coffee orders with no
yeah.
queues. Okay. And B2 using, so these are your business requirements, right? With advancement
Yeah.
using wireless technology. Okay, fine. So what are the user requirements you have?
First, I'm not sure, but with what I understood, I made these requirements.
Okay.
The first user requirement is manage coffee orders. It can be even online or in person.
See, word like or, okay, you cannot use
Okay.
here. See, or means what you're saying, do this or that. Okay, that you're not at all, it means that you're not serious, right? Okay, if I tell you, you can read this
Okay.
book or that book. Okay, so you're not being serious, correct? So or should not be used. See, if as a it's like you don't know what you want me to do, correct? Do you want me to develop online order or you want to develop in person? If you want both, then you have to say and. Okay, so something, if it is
Okay.
online, do this. If it is classroom, do this. Oh, sorry, if it is in person, do this, right? Okay, so never use or maybe. If you feel comfortable, do this. But it means that you don't want me to do. Okay,
Okay. So I'll change that to and.
right. Okay, order acceptance. What
Okay.
is order
And
acceptance? Right. So when order comes to this, so see, the first thing is it's not clear, which part of the whole life cycle you're talking about. Okay, so if the order comes to a kitchen, it is auto accepted, or it waits for someone to accept. Okay, so it will wait for someone to accept for 30 seconds. If no one accepts, the email goes to a manager or a red bulb blinks. Somehow that, oh, you have an order and you have not accepted within 30 seconds. So, so that is the objective. Or order acceptance means what? What does that mean? Okay. So you have to write clearly in some format.
okay. Yeah, I will make the changes for that. Then U3 is schedule delivery based on the customer's time requests. It can be whether they need it
No, but customer
immediately
says, I
or
want
maybe
in 5 seconds. Can I do it?
no, not in 5 seconds. It'll need a waiting time.
Right. No. So based on customer requirement, customer will always want, no customer will tell you that you give me late. Even if you are going there for, to spend time, even then you want order to come fast. I mean, given a chance.
Okay.
So what do you mean by that? So either you remove it or you explain it detail. So see, your
I just
business requirements, I'll tell you, your business requirements are correct. Okay. I don't see any, except few grammatical mistake. I don't think any problem is there. That's how you write. Okay. 5, 6. But your requirement is not like this. Your requirement is like, I'm telling you, do this. I'm telling you order preparation. Do you understand anything from that? Right?
no. I should have mentioned it as statements rather than terms.
Correct. So see, it's still one single sentence only, or maybe two sentences. Okay, I'm not asking you to write paragraph. Okay, two sentences, but it should be clearly telling who is going to do what, when, right? Who, what, when. Those things are missing. Okay, when will this happen? Okay, who's going to do it? Right? What it is. So I think these three has to be there.
Okay.
If I don't tell you what to do, when to do, you will not know what to do. So what, when, okay, what to do, when to do. Very important from your perspective.
Okay.
Okay. So now we go to system requirement, functional requirement, market decision. See, again, this is very high level. You should little expand this. Marketing decisions means what? Okay, marketing decisions does not see. So always you should have we got one verb, okay, associated, right? So
Okay.
perform marketing, right? Or avoid, perform, do. I mean, what action it does, right? That is not there. See, the previous one, acceptance, preparation, those are the words which telling you what to be done, right? But here I don't see such word. Like for example, second F2 you have purchase. Yes, makes sense, right? So recommended ingredient purchase. So you are saying that purchase there, that is the action. I know what to do. Ability to manage. I know what to do. Ability to manage similar orders. Okay, I know what to do. Probably your 2, 3, 4 are good. Okay, I don't see any problem there. F1 is definitely not good. Edit order list. Who can edit it? Customer. After placing the order, right? After placing the order, you are not supposed to edit the list. If a coffee is, especially in the food industry, how can you let your customer order, change the order? Because you can't reuse. Okay, see, if you're ordering some, say, pens, and they say, no, I don't want this, give me the other pen. Fine, because he or she can sell it to different customers. But food preparation is done, they say, no, I don't want this, right? So what will that hotel guy do? That person cannot take out all the ingredients, right, and keep it in the shelf, isn't it?
Yeah.
So in food industry, generally you don't have this order list editing. Maybe you'll get time. So maybe you get a minute, okay? Like once you place the order for a minute, you can change. After a minute is done, you can't change.
Okay.
Okay. Add promotion coupons, merge promotion and coupons with billing. Okay, so looks good. So
Yeah.
I think F6 and F7 can be combined together. Right? They are not different. To me, they look same. Because the purpose of adding promotion coupons is to, you let user redeem it while billing is done. Right? There's no other purpose of doing it.
Okay. And I'll add the non-functional.
If you see, I have not seen like all the websites that I have used, all the the e-commerce website. Everybody will ask you about coupons only just before the payment, right? So you enter and they will calculate and they will ask you to pay so much. Okay, so coupons are always entered at the at the end when everything is done, right? So, okay, non-functional code delivery locations and options. Again, you have to expand this. There's not first Q1 doesn't tell me anything. Order processing failure. So what? I mean, order processing failure when? Right? See, if order processing is
when ingredients are not available.
That's what I'm saying. If order processing is failing all the time, it is not a quality of service. It is functional problem. Quality of service is what it goes well sometimes, in some condition doesn't go well, right? So that is the quality of service, that it's not consistent. Sometimes it works, and every time it fails, it is a functional problem. It doesn't work that way. Your feature doesn't work at all. That's an example of functional. If it works sometimes, doesn't work sometimes, then you can talk about quality of service, that it is not reliable, not consistent, or something is getting changed. Understood?
Okay.
Okay. Traceability, fine. Okay, so that must be correct. So I'm not going to get into that. Any question here? Okay. And of course, Meenakshi you can also ask her any questions if you have.
In that assignment?
Yes, which just now Benedict showed us.
Actually, I don't understand the traceability. How, like,
what is traceability?
The U1F1. What is that? Is that a formula or?
No, no, you tell me what is traceability? Okay, I'll let explain. To explain her, can you share your screen and explain her, Benedict, what you meant, the traceability?
Yeah, I have just numbered the requirements, Meenakshi, like user requirements U1, U2, U3, U4, and I am linking the user requirement with my business requirement. So if my first business requirement is to manage effortless tasks on coffee orders with no queues, what are the requirements that will fall into the first business requirement?
No. So see, before you explain what is U1, F1, right? Just explain like how did you arrive at that thing? Okay, explain what traceability is from that figure that you have. Then you can explain. Okay, she is not able to understand what you have written. Okay, not that she didn't. She understood what is U1, F1, B1, but the way you have written, she has not understood. So explain her what traceability is, no, without getting into details of F1, U1. Later we can get into details. Not a problem.
Okay, it is like how the business requirement, user requirement, and system requirements are linked.
Okay, matched.
Yeah, match.
Okay. Got it.
Is that correct, Saurav?
Yes, yes. So can you go to that next page?
Yeah, just a minute. I'll take that quick content. Yeah.
Yes. So if you see B1, okay, colon U1, U2, U3, what it says is U1, U2, U3, U4, U5, U6, U7, U8, all are created in order to support B1. Okay.
Okay.
So it says that all these 8 user requirements are on link with user requirements are linked or are there because of B1. I told you, right? If it is not linked, that means that is not required. Okay.
Yes.
So all 8 are either are from this U6, U7, U8 actually supports B2. Okay. And then U1 is supported by F1, F2, F3, F4. So when you design F1, F2, F3, F4, 6, 7, you're actually supporting U1.
Okay.
Yeah, U1 is here.
Yeah. Okay. Any question here? Any more question?
No.
Is the voice okay?
Yeah.
Okay. Actually, my fan is running, so if there's no problem, I'll continue like this. Yeah.
Yeah. It's good.
Sure.
Can I stop sharing, Saurav?
Yes. Please stop sharing. Okay. The next topic is called root cause analysis. So what is root cause?
The main reason for any problem or
getting down to the main reason of any problem, right? Getting down to that point. Okay. Sometimes root cause may be clearly visible. You don't need any analysis. Sometimes it may not be clearly visible. So we have to do some analysis, right? Yes. For example, that we did earlier. Okay. The system, I think this is what we, where is that? Sorry. This one. Okay. So here we have done root cause analysis. So 5 whys is one of the technique to perform root cause analysis. Okay. So the reason why we perform root cause analysis is to find all the, okay, so yeah, to find the, not all the exact reason why something is happening. And if you want that problem not to occur ever again, you need to run it. Okay. So root cause analysis is actually done using, okay, there are some terms that you need to learn. Then we'll get into how it is called. So the causal factor, okay? Causal factor means a condition or event that results in an effect. So in that example, the two examples that we have discussed, do you remember those two examples? No? Okay, so what I'll do is go back to the previous slide, spend time to read it, okay, and then I'll ask you the questions. Read both the examples, keep in your mind, and then I'll ask you the questions.
You want me to read it loud?
You can read in the mind, okay, and when you're done, you let me know.
Yeah, done. Done, Saurabh.
Okay. So now if you go back, okay, so what is the cause? Okay, what is the causal factor or cause of the, you can give me any one of those, one example of from the two that you have read.
The main cause is like the direct cause is the manager doesn't.
I'm not talking about direct cause, I'm talking about the causal factor, the first one. Direct cause is second one. I'm talking about the cause. What is the cause of the problem? Okay, what was the problem? Tell me what are the two problems?
Like the employee didn't train well.
No, the problem is the car is not starting. The problem is the application has stopped working after upgrade. Okay, application stopped working after upgrade. Okay, or car is not starting. That is the thing. The causal factor or the cause is car not starting. Okay, application not running. That's it. Cause. Direct cause. What is direct cause? The first Y is the direct cause.
Okay. The battery is dead.
Yeah.
Battery is dead. Correct? Okay. That is direct cause. Yes. And in the second example,
alternator is not functioning.
Server failed.
Okay, so you're talking about direct cause, right? Direct cause is the upgrade actually changed the setting. Upgrade changed the setting. That's the direct cause.
Yeah.
Okay. What is contributing cause? Contributing cause is cause that contributed to the occurrence by itself would not have caused the occurrence. By itself, it wouldn't have caused. So upgrade wouldn't have caused it. See, upgrade changing the setting caused it. Okay, so these contributing cause, direct cause is the setting change, and the contributing cause is the upgrade. Okay, it doesn't matter. See, it's a contributing cause, not direct cause, because not every time when upgrade happens, things stops working. That's not the normal process, normal step. Okay, hundreds of thousands of upgrades happen every second. Okay, we don't face that problem. Okay, So problem is not the this thing. So the upgrade is only contributing cause. Okay. And then finally the root cause, right? When you ask why, so you get to the root cause.
Yes.
Okay. So how do you find, how do you analyze, how do you find the root cause? So we have something called as fishbone diagram. What we did was 5 whys, right? So we also have one more diagram. Okay, one more way of analysis. It's called fishbone diagram. So here you have to identify all the possible causes, all the possible causes. Okay, and then you start verifying if that's the cause, that's the cause, right? So you'll have all the causes of a problem occurring, and for any problem, for a specific problem, you will check, right? For example, let's say you have connected, okay, but you are speaking and I can't hear you, right? If that's the problem, all the possible causes, one is that you'll check your internet. Second thing is that you will check the speaker setting, that maybe, you know, I'm talking and you are not able to hear. Then you will check your mic setting, right? So these are all the possible causes of you not able to communicate with in online class. So, okay, so you know, first step is to identify all the root. Okay, so identify all the root cause, and then you need to also have corrective actions. Preventive action is the action that you are taking so that the problem doesn't occur again. Okay, so you have 2 steps that you need to do after root cause analysis. First is CA and second is PA. CA means CA, corrective action. The problem has occurred. What do you do now? Right? How do we fix it? Corrective action. Preventive action is how do we make sure that this doesn't occur again in future. Okay, and these are different tools that we use for root cause analysis. First one is called cause and effect diagram. Cause and effect diagram, I think that's the one here. Okay, so this is your cause and effect diagram. Okay, it's also called as fishbone diagram. Okay, so you have fish head, which is the problem. Okay, so this is a fish head. So this looks like a fish, right? This is a fish head and these are the fish bone, right? So on the head, we write the problem. And then you have major categories of problems: procedure related, people related, materials related, equipment related. Okay, and you see this example here. Okay, so just read this diagram for a minute, then I'll explain. Done?
Yeah.
Yeah.
Okay, so this is an example of problem is student failed to get grade A. What are different categories of reasons why a student will not get a grade A? It could be because issue with the subject, or issue at the school, or external factors, something which is not your control. Then you have miscellaneous, okay, which cannot be classified anywhere else. Personal issues or poor attitude. The subject is too difficult, or the student doesn't like the subject. Issues at school, difficult study environment. Maybe, you know, there is no proper environment at school, okay, or professor is not good. External factors like health issues, okay, or not enough study material available, right? So you know, you don't have enough material to study, that's why you could not get the grade. Then if you talk about poor attitude, lack of motivation. The student is not motivated enough to take up the subject, okay, or don't do homework, right? Or they skip classes. This is all about attitude. Then personal issues, cannot concentrate, not able to find time, there's problem at home maybe, okay, and miscellaneous like grade is not important for the student, okay, so he doesn't care about grade, so even if you get lowest grade, it's fine. Then it's bored with the subject, right? So these are some of the reasons why, okay, so the effect is failing to get grade A, and these are all causes, not root cause. These are all causes, and then for each specific student, we will have specific root cause, isn't it?
Yes, yes.
This is like, another example. I'll just wait for a minute. You read and we will skip to the next topic. Person is arriving late to work every day. Okay, so let's go back. So it's called cause and effect diagram. Then you have scatter diagram. Scatter diagram, okay, it shows proof cause and effect relationship. Okay, I'm not sure if this is there in the graph. Okay, so this is cause and effect diagram. Okay, so see, it's called scatter plot. Okay, scatter plot on x-axis we write the cause. Okay, and on y-axis we write the effect. Effect is the outcome, right? What happened, and cause is the underlying factor which impacts the cause, which impacts the outcome, right? So x, y. So you can say, y could be the marks that you obtain in class, and x is the factor that impacts y, right? Factor that impacts y, and x is, that is causing y. So if you draw the points, let's say I want to know if x has an impact on y or not. So scatter plot is when you can represent in terms of numbers, only then we can use scatter plot. Okay, if we can use in terms of numbers. So if you see, if you are increasing the x value, y value is also increasing. So this talks about the one, every dot represents two values here. Okay, one value on x-axis, other values in y-axis. So if this x is 3,5, that means 3 on x-axis, 5 on y-axis. So this is, if x is 3, y is 5. You are converting your values into numbers to see the outcome. So okay, so if you see, if the dots are moving in same direction, we say that x is responsible for y. X is responsible for y. Here if you see, when x increases, y decreases. X increases, y decreases. That means, again, x impacts y. Only thing is, if x increases, y increases. Here x increases, y decreases. For example, number of hours you spend on Facebook and marks obtained. So as you increase the number of hours spent on Facebook, marks will come down, isn't it? So there is a relationship, but the relationship is reverse. Okay, but there is a relationship. So see, if there is a relationship, we say strong relationship. Dots are closer, strong relationship, and the direction will be, will be like, positive or negative. Okay. Similarly, next line, if you see, again the dots are going in same direction. Okay, but dots are far away, not very close to like the first row. So here also there is a relationship, but the relationship is weak. We call it a weak relationship. And last row, if you see, it is like complex. Complex means, okay, for certain time, it exhibits one type of relationship and then it reverses the relationship. So here if you see, first it is showing positive, then negative. It could have been ulta also, like U shape. First it is decreasing, then increasing, right? So this is your reverse, upside down V or U, whatever, right? And if you have a U, it is like a opposite. But you can see both the relationship. You can see both increasing as well as decreasing relationship. So we call it as complex, where it has both. And the last one is like no relationship at all. If you see, the dots are everywhere, right? So there's no relationship. So in last case, X is not causing Y. X is not impacting Y. X is not causing Y. Any question here? Understood? This is when you can represent those values in terms of numbers.
Yeah.
Then we have SPC, Statistical Process Control. Okay. So this is again the basic foundation for the Six Sigma. Six Sigma topic has this foundation. What it says is, in process, there will always be variation, right? There's always a variation in a process. For example, we have to start this class on time, right? But it is not possible to start class exactly on time, isn't it? It's not possible. Definitely there is some variation, a minute early, minute late. But how much is the variation? Okay. Am I starting 10, 15 minutes early or 15 minutes late or half an hour late? Okay. So your process, if there's a less variation, expectation versus what you get. Expectation is that, it could, so let's say you feel that, you will get 70% in the exam. Okay. Score of 7 out of 10. But let's say you ended up getting 9. That is also a variation. You expected only 7, but you got 9. So there's a variation in the process. You could not predict correctly. When you're able to predict correctly, that means the expected value and the actual value will be in close range. So you expected 70, you got 90. That means your process, okay, variation is high. High variation means your process is not stable. Okay. And also sometimes, as I said, right, always variation will be there. So every time in life, we accept some variation. So if I come 2 minutes late or 3 minutes late or 5 minutes late, probably you will accept it. But if I come 30 minutes late, you will not accept it. So LCL stands for lower control limit and upper control limit. Okay. On either side of expected value, how much can you, you can accept, So if you can accept 10 minutes early or late, so your LCL, UCL is plus minus 10. But you can't accept 30 minutes. That is outside, beyond your control limit. Okay. And when it is beyond control limit, okay, when it is beyond control limit, that's when if you say that process is defective or process is not acceptable, okay, or you have problem with the process. Okay, 2 minutes, 5 minutes late, probably you will ignore. But if I come, if your control limit is, see, lower the control limit, more stable is the process. Higher the control limit, more unstable is the process. Okay, so to have a stable process, the limit should be less, not high. And alert for problem. So if it is within the control limit, there is no problem, right? But when it goes beyond the control limit, alert will be raised. Okay. So many a times when you see these software systems, right, they will continuously monitoring their performance of database, of hardware components, and moment there is a fluctuation, okay, the temperature should be between, let's say, 20 and 30 degree. It goes over 40 or 30, or control limit is 30. So if it goes beyond 30, even 31, alert will be sent that, it's getting too warm. So as long as it's within the limit, there's no fine. There's no problem. You are fine. But when it crosses the limit, that's when you will start raising, or you will raise that red flag. Yes?
Yeah.
So that's called, Six Sigma. Okay, that's the whole concept is based on this. Okay. Next one is prototyping. Okay, I'll give you time to read this, then we'll talk about it.
Yeah.
Okay, so prototyping is, okay, generally, okay, so let's say you tell me that, I need, that you tell me that this topic I need to understand, for example. Bad example, but then we'll come back to software. You tell me that, Saurabh, I need you to tell me this thing. I read it in some, job portal or whatever, wherever. I want you to talk about this. And let's say I have not done that before. Okay. So should I commit it? Yes. No. I'll say,
No.
give me some time. Okay, I will check and get back to you. Right. So I'll go. I will do some research. Okay, I'll understand what it is. Oh, it is this. I'll realize and then say, okay, yes, we will do it. Now, this is before, let's say, you join the course. Right. I'm not going to develop study material. Okay, I'm not going to make myself ready, but I'll just see what it is. Okay, and then based on that, I'll decide whether I can teach that topic or not. Right. If I think that I can talk about the topic, I'll say, yes, I know this, I can do it. Okay. And then if I don't know this, if topic is something beyond my this thing, I'll say, sorry, I don't know about it. Okay. But this I will do it before, correct? Before, you join, and let's say, before I start delivering or I start creating the whole process around it, right? So what is happening here is I am doing a prototyping. I'm going and checking whether can I do it or not. Okay, I'm not delivering. I'm not creating the complete tutorial or presentation, right? When you say yes, okay, yes, I want to learn from you, then I will create then I will create the presentation and slides. Right? So prototyping is building a small software working model. Okay, it has to be working model. Okay. Now let's say you have to build. If somebody says, if somebody says that I need to develop a payment gateway, and let's say you have never ever done payment gateway before, so you will not start building the software from scratch. You'll say, okay, let me see how payment gateway works. Okay, you'll design a small code, and if that works, you say, yeah, I know I can do it. We can do it. And when the order comes, then you will start developing that completely. Okay, so this is called prototyping. So even before you do the complete work, you will just test that difficult part. Okay, something which is difficult, something you have not done before, something you feel is difficult. You will add that component first, and when you are comfortable, that's when you will start from scratch. So prototyping is an early sample, okay, to test a concept or process, okay. So in prototyping, we create a model of the proposed solution, Prototyping also gives us tangible thing to view, to know, and you be confident, oh yes, I have developed it, I can do it, right? You get that feeling. And then you say to customer, yes, you can do it. Okay. So prototypes are of three types. One is called throwaway prototypes. Okay. And those are mostly non-software prototypes. Okay. So you design on PowerPoint. See, if I have to develop, if I need a software, right? You will not design it on a PowerPoint. PowerPoint, for designing, you show me, and okay, after that you have to throw it away. You cannot reuse it. But if you're delivering a software code, you can start building on top of it. So that's called evolutionary prototype. So you design a small one first, and then you started adding feature on top of it, on top of it, on top of it. Finally, it became a big, complex, a big enterprise application. So you are not throwing away. You are building on top of the existing one itself. Okay, most of the software projects are like this. Okay, you demonstrate when it works, then you start building on top of it. And third one is called simulation prototype. Here you don't create any prototype, but you design it on computer. Okay, you design it on computer. Okay, you are showing it on computer to show how it looks like. Okay, you are not designing actually. Okay, so when you're designing these complex bridges and things like that, they mostly design the simulation of it in computer. Okay, so first two is you're actually developing something real, physical, which you can touch and feel and see. Throwaway is not useful once you are done with your prototype demonstration or whatever you're doing, then it's not really useful anyway. Second one is where you can start building on top of it. So that's your evolutionary prototype. And finally, third one is simulation prototype, where you are using computer to generate a simulation, and then you're using that to show it to a client. Yes?
Yeah.
Okay. The next topic is called change management. Okay. As the name suggests, change. Change means what? There's already a process decided. There's already a thing. Like say for this training, they've already decided topics that needs to be covered. But for some reason, we have to change the topic. Okay. So already the product is decided. Okay. This is what we need to develop. Requirements basically is already decided. But then now you have to change the requirement. Okay. So why do you change the requirement? Change can be because of error. That means whatever you're delivering is wrong. If you realize it, then you have to change it now. Or because that you have understood better, right? You want to add more features to it. You want to expand, right? So, okay, so that could be one reason. And third could be external circumstances, market change. If markets change, then you don't need what you're developing. There's no point developing that, right? Or you may want to change something. So these are the three main reasons why you might want to change the requirements which you have already. So change management happens at the end after the requirements phase is done. You have got the requirement, everybody signed up, and you have given it to a technical team for development, right? And that's when customer comes, or you yourself will realize that no, we have to make the changes. Now this is complex because okay, already software team has started developing. They might have written a code based on your old requirement, but now if you change the requirement, the existing code may not work. There might be a lot of rework that is required, that could be required, right? Or you have to get approvals from all the other party involved, okay? More so problem when that old feature was already developed. Now you have to say, no, we need something change, modification. So whole work needs to be modified, right? So that's the challenge with change management. How do you make sure that the one that you have informed to all the respective teams and they're already working on it. Now you're saying what you have been doing is not good. We need to change it. Now, change can have small impact and very big impact. If it's small impact, it's fine, okay? You change it and it's not going to have any impact. But if change is big, it can have a lot of impact, isn't it? So it's not simply change it from one version to another, right? Depending on if nothing has been done, you just started, it's easy to change. That's what we discussed in day one itself, that change comes in, and if sooner you realize it, less expensive it is to fix, more easy it is to fix. Late you realize it, it can take a lot of time, lot of effort, lot of money. It is expensive to fix. Yes, you understood what is change management?
Yeah.
Okay, so change management happens after the requirement phase is done. If requirement phase is some change is required, that is part of normal requirements management only. Okay, that is not part of change. Change comes when you have approved. Okay, when I say you, it is you and the team. Okay, so you all have approved the change. Okay, signed and ready. Then you realize, no. Okay, something wrong and we need to rework. That's when the change management kicks in. It's done, requirement definition is done. While you're doing specification or acceptance testing, you will realize that there are some changes we need to do. Sooner you realize, cheaper it is to fix, easier it is to fix. Late you realize it becomes more expensive and it can become more complex to fix things. The requirements management is the process of managing changes to a system's requirement. Okay, so it's like, see, change management is like requirements management only, but the requirement management which is coming late. Once you are done with the requirements management and again the requirements come in, that's when we say that we are doing change management. So this is a process, okay? Everybody who was involved has to be informed and their signature got before you, okay, start using this change management thing for that particular project. Okay, so changes to the requirements should be documented and controlled formally. It's not that anybody will make some changes, because one document is being seen by multiple people. All the software developer will see, testers will see, okay, the business people will see, right? So that's why you need to control it. Okay, and change management process ensures that changes are made systematically. Similar information is collated for each proposed change. Other overall analysis is made about cost and benefit and timing of the change, right? The requirements document is documented. Okay, any questions so far?
No, sorry.
Okay, so this is the process that we need to follow when change comes in. Okay, first is record. As a BA, record it. Your customer or your stakeholder will say, okay, this is what we discussed earlier, but that is wrong. We need to redo it. So first thing is accept. Okay, record that the person has some problem. Then you analyze. Okay, as a BA, what we analyze is what is the impact of this change. Okay, do I have to change? Do I have to change the whole process? Do I have to change one requirement? Do I have to make code changes, right? Is it inconsistent with other changes that we have spoken about, right? So that's what you will do in the analysis. You will also call the teams which are impacted, okay? Team that has developed it before, teams which are currently working, and you will show them the recording, the thing that you have captured. And they will give their own feedback, okay? Possible, impossible, possible with $10 million as expense, which is same as not possible, isn't it? So then you'll say, okay, based on that, you'll decide what to do, right? And then finally, the changes will be, if you decide to go ahead with the changes, then you need to add it to the implementation plan, right? Somebody will take it and will then start implementing it. Okay, so you have record, analyze, decide, and finally implement. So these are the stages of requirements management. Okay, so first you need to record the changes, then analyze the change, then you decide which should be accepted or which should be rejected, right? And then finally you will implement it. Okay, so this is what I said. This is what? The last topic for today is configuration management. Configuration management, any idea what it is? Yes, no?
After the completion of the any.
Correct. You have to make that installer, right? Which can be used by the client or by your implementation team to implement it. So it is the final output product that goes to the customer. Final output product. So you will not be sharing the code, right? Code is your confidential thing. So you won't be sharing the code. You will be sharing this final output which goes to the customer and customer will implement it. Okay. So for every new version of software, you have to create a different configuration based on the OS, right? When you're downloading a software and when you go to this website, they'll say, okay, which version you have to download. You want to download for Windows or Linux or, you know, iOS or Apple system. So if they say Mac, if you say Mac, then they'll have a different file. If you say Windows, you'll have a different file. See, the code is same. Code will be written in Java or C++ or whatever, whichever language. That language is same, whether you're developing for, you know, Windows machine or your Mac machine or your iOS or Android, it's the same code, right? But the installer has to be different because installer, the way things work on Apple is different than the way things work on Microsoft, right? So you need to create multiple versions of the same code base. Same code. Code is not changed, but configuration is changed. That's what we call configuration management. Configuration is changed based on your different machines, different OS, okay, or sometimes offering different functionality. Okay, so that if you the same core functionality is same, but now you have to implement it at say in China. So you need to bring in new functionality. More or less, the functionalities are same. Okay. But in some rare cases, functionality will be different because you need to have Chinese language support. So it becomes little different. Okay. So that's why you are tailoring it to every requirement from the user. Okay. So configuration management is concerned with managing evolving software systems. Okay. Version controlling is one important aspect of configuration management. Okay. So it involves development and application of procedures and standards to manage evolving computer software. Okay. So documentation is also part of configuration management. What I just told you is sharing the code base from your machine to whatever machine is getting installed. But another thing is the documentation, the process, right? Which is also important and maybe seen as part of more general quality management process. So it falls under quality management. Okay, so most of the companies they include configuration management in quality management. Okay, because a lot of things on quality also matters here. Okay, so when you release it, the first product is released. It's called baseline. Okay, and from baseline, every time you develop a new software, you will take one code as a baseline. First time you're developing, you develop the code and you upload it, and that is your main code. And from next time, you have to create the baseline of the product. Okay, so we say that version 1 is baseline product. So next versions, whatever versions create, you have to create from version 1. Okay, so configuration management planning is about, you know, as soon as the process starts, be a process, you have to think about it, right? How many OS it has to support, how many browsers it has to support, those things will come in the first day itself that you're talking about. Okay, and then you talk about specification, designs, programs, tests. This is true with any of your software system. Thousands of separate documents may be created. Okay, so based on each of these, you'll create a separate document. That's fine. So can somebody read this for me? The configuration plan, little louder so they can hear.
Defines the types of documents to be managed and a document naming scheme. Defines who takes responsibility for the CM producers and creation of baselines. And defines the policies for change control and version management. Defines the CM records which must be maintained. This describes the tools which should be used to assist the configuration management process and any limitations on their use.
Okay, so see, CM and change management is still important. CM is something that you have to be aware of what it is, right? So here you're talking about configuration management. How do you manage different versions? See, you release a software. The second time when you're developing another version of it, you will not start coding from scratch, right? You will take the existing code base, okay, and then you start. So that's what we call it as configuration management. Okay. Change management and version. Okay, so we'll talk about this. Okay, so see here. So what is the baseline version here? If you see, version 1.0 is the first version. So the first software version that was released or launched is version v1.0. Okay, so this is what the first version is created. Okay, fine. Then v1.1 is created from where? Is created based on v1.0. Okay, now your v1.1a is also created from version 1.0. Okay, so it has three types of numbers here: version, variant, and release. Version 1.1, 1.0, 2.1, 2.2, that's called version. Okay, version will have your numbers. Okay. Then you have variant. Variant is which is functionality identical, but non-functionality will be different than the previous one. So feature-wise, it's all the same. Okay, but you created a new file for Windows and one file for, say, Mac. Feature is same. So there, the version is same. Okay, but variant is different. Okay. So in the diagram that you see here, 1.0 is the version and AB is the variant.
Variants.
Okay, so V1.0 was the baseline. Then we created 1.1 or based on 1.0. We created 1.1A also on V1.0. Okay, V1.1B was created on V1.1, not on V1.0 or 1.1A. Created from V1.1. Okay, so this is how you have to read this diagram. This diagram shows which version was released when and which baseline was chosen by different versions. Okay. So I think with that we will end our session 2. Now tomorrow when we meet, we will get deeper into discussion. Okay. Some more hands-on work that we will do. So I told you, right, 3 levels. First level, second level is also done. Now we are going to third level, which is the ground level.
Okay.
Okay, any question? If not, we will end the session here.
Saurabh, can I just get your number, please?
Oh, yes, I will send it. But mostly we're supposed to work with, Ram, but I'll just share.